So we're going to look at some more examples since this can be a tricky concept for students. So we're going to find the volume of the solid generated by revolving the region bounded by the graphs of the equations about the given line. And we're going to revolve around y equals 6 and y equals negative 3. So our two functions are y equals x squared, y equals 4x minus x squared. So you're going to graph it in your calculator, and you will get something that looks similar to this. And then the line that we're going to rotate around is y equals 6. And you're going to find your two intersecting points. It intersects at 0, 0 and 2, 4. So we are talking about rotating around a horizontal line, so we're going to use x bounds. So we're going from 0 to 2. We're going to put pi out. So we're going to talk about top to bottom, but remember you're going up. So this is going to go first. So this is going to become your top curve, and this is going to become your bottom curve because we're going up above it. And remember what we said, if it's above the region, you're going to take that and subtract. So this curve right here that is now our top curve is our positive parabola. So we say 6 minus x squared squared minus, and now we're going to say 6 minus, this becomes our bottom, and then put it in your calculator, Math 9. Now, let's look what happens when you change and you're going around y equal negative 3. Y equal negative 3 would be down here. So I'm still going around a horizontal line, so I'm still using x bounds and y equal equations. So but remember, if we're below the region, we're adding to it because we're making the radius longer. So we're going this way, so our top curve is going to be our negative parabola. So we say 4x minus x squared plus 3 squared minus x squared plus 3 squared. So you're adding the 3 to that, and you get that answer. So now we're going to look about y equal x squared and y equal 4x, and we're going to revolve around x equal negative 2 and x equals 7. These are vertical lines, so you have to convert to x equal equations, and you have to use y bounds. So you're going to graph it on your calculator and get your intersecting points, which are 0, 0 and 4, 16. Let's do the x equal negative 2 line first. So that's to the left. So remember, when it's to the left, you add it to the function. First of all, I got to convert. Here's the algebraic way to get your intersections if you're on a non-calculator part. But most all the time, this is on calculator active. It's very rare to have a non-calculator. But I'm going to convert it to x equal equation and both of these. So I'm going to come over here, and we're left, so we're going to add to it. So we're going from 0 to 16, which is our y, and we're going right to left. So which one of these, if you're going around this, this is our right curve and this is our left curve. So we do square root of y, which was our x squared, plus the 2 squared minus our conversion y over 4 that converted from that, plus 2, and put it in, you can get 85.33 pi. Now, if you're going around x equals 7, this is to the right, so we're going to take this 7 and subtract our functions out to get our radiuses. And if we're going this way, what becomes our top curve? This one, our straight line. So we're going to go 0 to 16 again. We're going to say the 7 minus our y over 4, because this one is our curve that's going to go first. Minus 7 minus square root of y. And you get 106. R be the region enclosed by y equal the square root of x minus 1, the vertical line x equal 10, and the x-axis. And we're finding the area, finding the volume if it goes around a horizontal line y equal 3, and finding the volume where it goes around a vertical line x equal 10. So let's take a look at what we're going to do. So we're going to graph in our calculator. The draw line again, it won't save it. So second program, which is draw number 4, and we'll say 10 and hit enter. Okay, so we're talking about this right in here, this region, and we want to know the area. So if you think about this as your top curve and this as your bottom curve, and this is represented by x equals 0 because it said it was bounded by the x-axis. So we are going to say this curve minus this curve. Now notice our bound starts at 1, not 0. So we're going to go from 1 to 10. So if we go math, let me clear the screen out. So if we go math 9, we're going to go from 1 to 10. Now we're just doing area, so we don't have to do the pi, and we don't have to do any squared. So we're just going to say x minus 1, and you could say minus 0, but of course you don't need to, and hit enter. And your area is going to be 18. So now let's look at the volume. So on part B, it says that you want to find the volume when it's revolved around a y equal 3 line. So this is what our graph looked like in the calculator, and y over 3 is going to be above it. So remember, when it's above, you're going to take that line and subtract. Now you're going rotating around here. So what is your first curve? 0. So you're going to say 3 minus 0, because that's y equals 0 is your x-axis. So 3 minus 0 squared minus 3 minus this curve. Square root of x minus 1 squared dx. Put it in your calculator and you will get this. So remember, if we're going up, we're taking our line and subtracting our function, and this becomes our top curve that goes first, and this becomes our bottom curve. Now, the next one wants to go around x equal 10. So that is a vertical line, and we're already at the 10 line. Okay, so remember, when we go around a vertical line, we have to use y bounds, and we have to use x equal equations. And if we're to the right of the function, we subtract. So here's our 10. Now, think we're going this way. So what curve is going to go first? This one, and then this. And so down here, I've converted to my x equal equation. I've plugged 10 in to get my y. And I plugged 10 in up here to get my y. So my bound is going to go from 0 to 3. And I'm going to say, since this is right of the function, I'm going to say 10 minus this curve, y squared plus 1 squared, minus 10 minus 10, because this is x equal 10. So 10 minus 10, which will basically be 0. And you will get this. So if you'll look on your pass out, you might can see it better, your calculator, and you would get your intersecting points. So your intersecting points are these, and I will show you in the calculator in just a minute, and you can store them as we've done previously. or you can just type them in, whichever you want to look at. So before we put it in your calculator, let's look at what we're talking about. So when we're talking about the area, we're going to do the top curve minus the what? Bottom curve. Okay? And we're just going to use x intervals. So let's look at that in our calculator. So we're going to type our functions in, ln of x and x minus 2, and we're going to graph. And you see that it looks like what's on your free response paper and your pass out. Then we're going to get our intersection points. And wherever your cursor is, you can get that so you can see our upper bounds. And now I'm going to get our lower bound. Went too far. Enter, enter, enter. And you see our lower bounds, which is on your paper. Now I'm going to store those just so we can use them. So I'm going to type our lower bound first. Make sure I typed it right. 4, 3, 4. I'm going to hit store alpha A and hit enter. And then I'm going to put our higher bound. Notice I'm using X values because we're going over a horizontal line in part B. Make sure I type that right. 32 store alpha B. Again, you don't have to store, you can just type it in. So let's look at the graph again. So in part B, it says that you want to rotate around y equal -3. So that's going to be a horizontal line below your region. So remember, when it's below your region, you're going to add to your radius. And you need to figure out which way you're moving. So you're moving this way. So your blue curve will stay top. So we'll come in here and hit Math 9. And we're going to do alpha A, alpha B, and we're going to put parentheses 3 plus ln of x, because that was our top curve. And then I'm going to close that off so I can square it. And then minus, and we're going to do parentheses 3 plus parentheses x minus 2, close that parentheses, close that off, and put a square, and put dx. And let's make sure we've typed it right, got all our parentheses right. And you see you get what's on the paper, 10.886 pi, or you can multiply it times pi, depending on how your answer is written. So part C says write but do not evaluate an integral expression that can be used to find the volume of the solid generated when R is rotated about the y-axis. So they'll do this a lot on the AP exam, just have you set it up. So if we're going to go around the y-axis, that's a vertical line, so we have to make x equal equations. So if I take the e of y, e of ln of x, e and ln go away, so I get e to the yx. And then, of course, I solve for x on this one. Now, we're revolving this away, so what's going to be our right curve will be this, and our left curve is going to be this, and we're going to use our y values. So we're going from negative 1.841 to 1.146, and we're going to use y plus 2 squared minus e to the y squared dy. That easy, that simple.